Hello everyone. In today's video, I'm going to be talking about gist memory, an agentic memory technique that was released by Google DeepMind last year to tackle the challenges associated with enabling LLMs to reason over long documents like academic papers or legal texts without hitting context window limitations. We'll also talk about how this is a method that particularly benefits from the fast inference solution provided by Cerebras. Let's start with a quick overview of what gist memory is and then dive into the details. Gist memory works much like human memory works. When we read a book, we don't remember every word in detail. We remember concepts and perhaps summaries of sections that we keep in our heads. Then when we need greater detail, we refer back to the original text and retrieve what we're looking for. With gist memory, our agent will intelligently break long documents into pages, create summaries of each page, and then selectively reread only the most relevant sections to answer our questions. Let's dive into the architecture. So our agent has 4 key modules that work in sequence. First is the parser. This module fetches an archive paper, converts it to clean machine-readable HTML, and extracts the text as a simple list of paragraphs. Then we have the paginator. Instead of just chopping the text into random chunks, the paginator uses an LLM to find semantically coherent breakpoints. This ensures that we create pages that end at natural points, like the end of an argument or a topic shift. Third, we have the summarizer. This module reads each page and asks the LLM to generate a concise summary or a gist. This collection of gists then becomes the agent's memory. And finally, we have the Q&A engine. When we ask a question, the engine first consults the gist to decide which pages are relevant. It then retrieves the full original text for only those pages and uses that enriched context to generate a final answer. In our cookbook, we have everything set up for you to get your environment ready quickly. You'll need the Cerebras Inference SDK and a Cerebras API key, which if you don't already have one, please head over to cloud.cerebras.ai to get yours. Once we have our environment configured, we can go ahead and start working on the architecture. Here we have the first component, which conducts the parsing of the archive papers. These functions take the links, fetch the HTML content, and extract out the paragraphs, which become the text that we'll be working with. And then we have the core logic of our gist agent itself. This process relies on a series of targeted LLM calls, each with a specific prompt. The first step is intelligent pagination. For intelligent pagination, we gather about 600 words of text and insert numbered labels between the paragraphs. We then send this to the LLM with a prompt that asks, please choose the label that marks a natural place to break reading. The agent then uses the LLM's choice to define the page boundary. Next, for each page we just created, we generate a gist. This is straightforward. We send the page's text to the LLM with a simple prompt, please shorten the following passage. The result is a concise summary that we store in our agent's memory. Once we have all of our gists, we can move on to the interactive lookup and question answering component of the agent. So the Q&A process is done in 2 steps. First is the lookup step. In this stage, we give the LLM all of the gists we created and the user's question. We instruct the LLM to not answer the question yet. Instead, just identify which page numbers you need to read in full to find the answer. Then comes the answering stage. The agent takes the page numbers the LLM requested and retrieves the original full text for those pages. It combines these full text pages with the gist for all the other pages into a hybrid context. This context is sent back to the LLM with the question to generate the final informed answer. And finally, we have our final block, which initializes our gist agent, prompts for an archive URL, and then calls the process document method. So let's actually go ahead and try it out and see how it works. So as soon as I give it an archive paper, which this one is the famous attention is all you need paper, which introduced the transformer architecture for neural networks, it goes ahead and does the pagination, completes the process, and then allows me to simply go ahead and chat with the agent. So here I can ask it, explain how self-attention works. This is a core component of the Transformers paper. So I see first it went ahead and decided which pages it needs to read from the summaries or the gist that it created. And it decided on pages 2 through 4. And using pages 2 through 4, it generated the final answer. So there you have it. That's Gist Agent, which can read and reason about long documents thanks to its memory technique. These type of techniques and methods are really exciting because they extend the capability of an LLM by giving it access to important components, such as in this case memory. And many of these techniques really only become practical with access to high-speed, low-latency inference, such as the one we provide at Cerebras. Processing just this one document required over a dozen LLM calls, and if each call took many seconds or up to a minute, the experience would be painfully slow. If you're interested in working with the code we've shown here today, you can find a link to the notebook below in the description. And for more cookbooks like this, head on over to the cookbook section of our docs site at inference-docs.cerebras.ai/cookbook.